some things that come from the quadratic formula, and as well as the Pythagorean theorem. The distance formula, and we bring up distance because, again, quadratics get involved, or the process of squaring gets involved. So it says here, find the distance between the points 6, -5 and -8, 3. Pretty simple situation, really. I'm just going to take my two x coordinates, subtract them. And here it doesn't matter what order you're doing it, because ultimately you are going to square them. So even if you subtract them in an order going to be negative, it's still going to end up being positive. So when I do this, I get, the square root of 260, which I could write simplified as 2 times the square root of 65, or I could write it as 16.125, approximately. It's not exactly what it is, but it's approximately. Please remember, a distance is a single value. It's telling you how many whatevers are. If it's like me graphing something, I'm just going to say usually units. But do not write distance as an ordered pair. An ordered pair is a specific coordinate. It's not a distance between two coordinates. For part B, it says find the 2 points on the y-axis that are 8 units away from the point 4, 6. And how will we find an answer to this? Okay, in fact, there's two answers to it. So I'm going to kind of graph the situation here. I'm going to kind of I give you the entire answer here, but let me kind of walk through it a bit. Okay, first I kind of draw the situation. Here's 4, 6. So I'm not drawing a super fantastic, accurate graph or anything. Okay. I'm going to have 2 points on the y-axis, 0, y1, 0, y2. And I'm saying they're 8 units away from 4, 6. I mean, there's going to be two. Now, I don't know if this little picture I'm drawing is accurate enough to say, okay, it's going to be in this vicinity. I mean, because one of these y's might be negative. They might both be negative for all I know, but chances are I'm going to have one that's kind of above the value of 6, as far as, because it has to be like, and the one's going to certainly be below, but how far below, I just don't know. Okay. So, I'm going to use the distance formula. And what's going on with this is that, we have 4, 6 as being a coordinate. We have the other x coordinate of a point being 0. Okay. I just don't know what the y could be. And we end up getting y1 and y2 because the fact that we're eventually going to take a square root, it's going to produce two different answers. So the 4 and the 6 are being put in there because that's a point that I have both pairs for. X2 I'm letting it be 0 because that's going to be like one of those 2 points I have out there, and I'm letting this y represent one of those two y coordinates. And so I go through and simplify this. I square both sides to get rid of the radical, which leaves me with 4 squared plus 6 minus y squared. 4 squared 16, subtract that from both sides, I get 48. I could choose to, FOIL out 6 minus y squared, but that creates more work than I have to. It's already in a factored form. I already have y, a single y value only, so why go through the procedure of making my life difficult? I'm going to square root both sides, which gives me the square root of 48 plus or minus, and that can be simplified as 4 times the square root of 3. I would then subtract 6 from both sides. Well, the way I did it here is I moved the y over and got 6 equals y plus or minus 4 times the square root of 3. And to get rid of plus or minus, I would do a minus or a plus and get that, essentially y is going to be 6 plus or minus 4 times the square root of 3. So those are my two answers. One of them is going to be 6 plus 4 times the square root of 3, and the other is going to be 6 minus 4 times the square root of 3. And just for the sake of knowledge, 6 minus 4 times the square root of 3 is about negative 0.928, which means that my original picture is not, accurate with respect to where, the y coordinates would be. But again, I'm just using that picture to kind of give me an idea of what I'm looking for here. So keep that in mind. It's good to draw pictures. Try to scale them as accurately as possible, but sometimes you're not going to know until you get to the very end. So, don't always assume that whatever you're drawing should be treated as if it's drawn to scale in any way. So,